Okay, in this video we're going to talk about tangent lines and instantaneous velocity. Now in this video there's not going to be any equations that we're going to be talking about, but the things I talk about here relate to a very important skill, which is analyzing and looking at the tangent lines for a position versus time graph. Okay, so let's take a look here. We've got a position versus time graph for an accelerating object. And this actually goes with the position versus time graph of a cart that's rolling down a ramp, right? You saw this. It was an upwards opening parabola. Now, what I'm interested in doing is looking at the average velocity. And we defined this last unit as the change in position over the change in time. And this actually looks like a slope, right? The change in y over the change in x. Graphically, what this looks like is if we were to take 2 points in our data, I'm going to take a look at the first point and the last point. And the average velocity would be this line that we draw between the first point and the last point. Okay, that would be a graphical representation of the average velocity. It's just the slope of this line. Okay, and it's the velocity when we take this whole time interval into account. Now, for this unit, we're interested in looking at the instantaneous velocity. So what I'm going to do is we're going to look at what an instant in time looks like. And an instant takes place in a split second, in 1 second. Okay, so here I'm going to shrink our time interval a little bit. And the 2 points I look at now will be this point and this point. And if I wanted to take a look at the average velocity would just be, again, the slope of the line that connects these 2 points. Okay, so nothing really new here. All we're doing is we're shrinking the time interval, getting smaller and smaller until we come up with an instant. Okay, I'm going to shrink it a little bit more. This is now our time interval. And the average velocity, again, is going to be given by the slope between these 2 points, the point on the left of our interval and the right of our interval. And at this point, I think you're going to see where I'm going with this. Next, I'm going to shrink it so that our time interval is infinitesimally small. Okay. And our time interval is just a moment now. So you can't even see the width of it. And what we have here is this line, if we continue along this pattern. And in math, what we call this is a tangent line. Okay, and what happens is if we were to take the slope of the tangent line, we would come up with not the average velocity because it's not taking place over a time interval, it's at a moment. The slope is the instantaneous velocity. Okay. So how does the slope of a tangent line change as time increases? Well, let's take a look at our data for the cart rolling down the ramp. Okay, let's go back, remove any drawings I made on this picture, and I'm first gonna take a look at the tangent line here at the beginning. I'm gonna take the tangent line here sometime in the middle of its journey. And I'm going to take the tangent line here at the end of its journey. And at this point, I just want you to observe how the steepness changes. So the first tangent line looks like this. Second tangent line looks like this. And the third tangent line, whoops, looks like this. All right, so take a minute and think of how the steepness is changing. If we compare all of that, it looks like our steepness increases. And we want to ask ourselves, does this make sense? Does it make sense that the steepness increases? Okay. And we think, sure, it does make sense. It does make sense that our steepness increases because first, in the previous graph, we had a positive slope. Not super steep, but still positive. So I'm going to place a point here that goes with the slope of the first tangent line that we drew in the last slide. And the tangent line that we drew in the middle, also positive. So it goes above the time axis, right? This is all positive velocities we're talking about. And it got steeper. So it makes sense that our velocity has increased from before. And at the very end, we had the steepest line. So we had the greatest velocity, all positive slopes. So comparing with the previous graph, we noticed that the tangent line slopes increased as time increased, right? The three lines, as time moved forward, got steeper and steeper and steeper, which makes sense because what we have here is the object is speeding up. So the velocity increases because the tangent lines got steeper and steeper. Okay? And the big moral here is the slope of the tangent line of a position versus time graph at a certain time represents the instantaneous velocity at that moment in time. Okay, so rewatch the video. Make sure that we understand the relationship between the tangent line slope and the instantaneous velocity. Those two are synonyms. They're the same thing. Okay, we'll talk more about this in class.